Hello, and thank you for joining today's broadcast on delivering AI models with Redis. My name is Britiana Andrade, and I will be your moderator for this webinar. Our presenter today is Kyle Davis, Head of Developer Advocacy here at Redis Labs. Today's webinar is being recorded, and all attendees are in listen-only mode. At the end of the webinar, we will have a Q&A session, but you may post your questions at any time in the Q&A section of the control panel. Following today's webinar, an email with a link to the recording will be sent to you for future viewing and to share with your colleagues. With that, Kyle, I'd like to turn it over to you.
Hey, everybody. Hi, I'm Kyle. As Britt introduced me, I'm the Head of Developer Advocacy here at Redis Labs. And today we're going to be talking about AI models and how to deliver them with Redis. So let's go ahead and get started. When we take a look at things, let's take a look at the evolution of AI over time. Everybody has seen these type of charts before, but I think they're really illustrative of evolution and how things grow, right? So if we take a look here, before AI, really, we had people doing kind of advanced analytics on things to gain insights, right? And that was effective. You can count things, you can create averages, you can get a lot of value out of these very simplistic mathematical operations. And it's really interesting, and we saw a lot of things coming forward with that. But then things moved along, and we had people developing algorithms for specialized use cases. And algorithm is a buzzword for many people. You might talk to somebody and they say, "I developed an algorithm that did this or that." Well, that's great, and that does represent even more insight than just kind of doing some of the analytics on things. And then we moved on into some really interesting and much more deep and more advanced things where we're doing convolutional neural networks and natural language processing. These represent further advances, and as you can see, it's more upright and more like what we know today. But what is the future, right? Where are we going to get to this final evolution? Today we're going to explore that. So let's look at a typical AI development cycle. This can represent anything, but this is kind of what you might see when people are trying to deploy some sort of AI into the real world. So, data goes into something like Spark, and you manage the training in Spark. You have a lot of data at this point, just a huge amount of data. You generate your model and you save it into something like Parquet, which is a file system. So it's traditional storage. You take that and you load that into some sort of custom server that's designed for whatever type of model that you have. If, for example, you might have some sort of custom TensorFlow serving system here. And then you have a client application that will ask questions of that custom server. Okay, and then from there, that's the whole process, right? All along this whole series of steps, there's some specialized knowledge. These things are not straightforward very often. The number of people running these different types of things is, in comparison to developers, especially developers of Redis, for example, people who use Redis, very small numbers. But the most important thing is it's not real time when you're doing this. You have a very significant delay, and that's a problem. And we're here at Redis Labs, we don't like things that aren't real time. So let's see how we can help you out here. When the world is looking at things today, the need for this kind of real-time AI is apparent. We have in the upper left-hand side, we have Waymo, and Waymo is a self-driving car, and self-driving cars have to make many decisions to navigate the roads. There's a lot of stuff that's straightforward, but a lot of stuff that's not, and it has to rely on AI. And when you're a vehicle moving several tons around at 100 kilometers an hour, you need to be instant. Moving to the right side at the top here, you have something as commonplace as a phone scanning your face to identify who you are. That's something that a lot of us have in our pockets today. But inside of this, there's a lot of stuff going on, and it needs to do that. Now, both of these things are, both the Waymo example and the example of the phone, these are all happening probably on device. There's probably a model loaded, it's running on device. There's no appreciable amount of network involved. So they can rely and perform these things pretty well, but it relies on a relatively limited amount of data that can be stored in a local instance or a local storage system. As we move to the bottom, we start looking at things that are connected to the network and have to actually be able to look at a more global scope. So we have somebody doing a contactless payment, right? Now, in the past, we had different levels of security. If you're old like I am, you realize you had carbon copies and people would run some sort of mechanical thing over a credit card and then they would sign it. And then we moved to things where we sign a little display, and that was some sort of validation. Many parts of the world use a PIN number to validate the transaction. But when you have the contactless payments, basically the reason we've enabled that is that there's a degree of knowing who is, or knowing that the card is valid. But we also have to know who's doing that, because there's really not a lot of interaction that's required in contactless payments. And that requires a great degree of fraud mitigation to make sure that the person who's actually doing that payment is the valid person doing it. So that has to happen in an instant as soon as you're touching that terminal that's running the transaction. And then on the bottom right, we have the situation of a navigation app that has knowledge of all sorts of things. It has knowledge of maybe speed camera traps. It might have knowledge of traffic conditions. It might have knowledge of all sorts of other factors as well. And to navigate this and be able to effectively go around the whole system, you really have to have some sort of intelligence there. You can only get so far with algorithms, but you have to be able to do that in a very quick way, because if the traffic conditions change, which if you drive much, traffic conditions can change quite rapidly, it has to provide a real-time view of the data and a real-time prediction on what's going to be the easiest route. And nothing ruins your day than getting stuck in traffic when told by an app that you wouldn't be. So where do we go from here? The next evolution is instant AI. This is where you'll see the world going. As before, you may have had situations where AI was provided to you in some sort of batch process, and then predictions were served off of this. That world is quickly coming to an end, where now you have to provide AI predictions on an instant level. No longer do we live in a world where once per day, twice per day, any of these type of frequencies work. You need to be able to take that prediction and run it in literally an eye blink. And that's where we are. So I want to talk a little about Redis, and then we'll talk about how these things obviously connect up. Our roots are in open source. Redis is an in-memory open source database. It's used in a lot of different ways. If you are in a modern business and you're not running Redis, you're in the minority. It is everywhere. And then Redis Labs, my employer and people providing this webinar today, we have what's called Redis Enterprise. It takes Redis and basically builds a set of tools around it that makes it a enterprise-grade, high-performance, multi-model database. And what it can do is provide instant experiences for modern applications. So while Redis is great for a whole lot of use cases, Enterprise just takes it to the next level and allows you to do a little bit more with it at larger scales. So it really does some amazing things in that regard. So just a matter of scale in our community, last year we crossed over the 1 billion Docker pools on Docker Hub. Now, I'll be honest with you, we all know that 1 billion Docker pools does not represent 1 billion applications running Redis. Some of this is CI and CD pipelines, stuff like that. But still, it's amazing. That's just Docker. That's not people who have gone and are using it as a vendor from a vendor supplied version, or people who are building it themselves. It's just tremendous the amount of times that Docker or that Redis has been installed. If you really start thinking about the whole worldwide impact of it. It's the most loved database for 3 years in a row. The news just came out for the 2019 survey, I believe, and so we had 2018 and 17 as well. And what that's by Stack Overflow. And basically, what they said is these are the database that I want to use. I've never used it before, or database that I use now and I want to continue using it. That's what most love means. And we found that when people start using Redis, they really want to continue using it because it's a lot of fun, it's rewarding, and it can do a lot of things that really make applications better. The differentiators for Redis are basically threefold. High performance is the first thing that people associate with Redis. It really changes the game when compared to disk-based databases. And we'll get into each one of these points in turn. The simplicity of it, gone are these arcane and largely incompatible query languages. Replaced is a series of data structures with commands that are very easy to memorize and understand. And then they can be composed into very powerful solutions for your particular use case. And then finally, the extensibility of Redis. Redis is not just locked into a certain set of abilities. Redis has built-in extensibility, which allows it to change dramatically what it can do. And we're going to get into how that change happens, especially when it comes to AI real soon. So performance, these are a couple slides that I've been familiar with for a couple of years. They're really powerful in a lot of ways. I want to focus on, I'll talk a little bit about the one on the left. In that case, where we're looking at Redis compared to Couchbase, Cassandra, and DataStax. In this case, you can look, and this is our Redis Enterprise version. We're performing the line chart here is the lower latency, and the bar chart that's superimposed behind it is the throughput. So as you can see, both the latency is lower and the throughput is higher compared to this. And this was done by Avalon Consulting Group, which is an independent person who ran the benchmark. Now, on the right side is the Google blog, and I think this is a really cool thing that they produced a couple years ago. In this case, they did a benchmark independently, again, not spurred on by Cassandra, Couchbase, or us, and said, how do you deliver 1 million writes per second? And how many servers do you need? In this case, Redis needs 2 servers to deliver 1 million writes per second. And if you're used to traditional databases where writes are more expensive, Redis being natively in memory, reads and writes are the same cost, the same performance impact, right? Which is pretty unique. And that really puts us in a unique territory. So we take 2 servers on some pretty beefy instances here, but still just 2 servers. On the same type of servers, Couchbase took 50, so 25 times 2, and Cassandra took 300. So pretty powerful difference when you look at this. And if you look at the cost, it's just going from a used car price to a fancy mansion, right? It's a pretty big difference. Simplicity, and I've spoken this a little bit earlier. I love this slide because it shows the different data types as Lego blocks, right? And I think that's one of the best analogies. You can take these Lego blocks, you can put them together, and while the block may represent something very simple, by in the end you may have something quite complex. So we descend from the key value store version of databases. And when I say descend from it, this slide illustrates that we're not just a key with a blob on the other side of it. We have the ability to have these rich data types that define how you use them and how they can be used. Each one of these comes with their own set of commands. So, for example, you might have the ability to manipulate a list, which is somewhat similar to a linked list, or specific commands that manipulate a set, or even some things that work with our more advanced data structures like hyperlog-log, which is a probabilistic data structure designed for estimating cardinality, and streams, which allow you to create kind of these really interesting log or event type patterns that can be used to knit together these complex systems. So really kind of interesting way of doing things, and quite distinct from other databases in the database world. And finally, I want to talk about our extensibility, and this is a great part to really go on, because for a long time Redis did have those Lego building blocks, and that was it. And people loved those building blocks, and they said, I really want to use that for my use case. And that was hard because we believe in really good software at Redis Labs, and when looking at the open source product, we wanted to prevent scope creep. We wanted to do a few things and do them well. But people still loved Redis and they wanted to do it. So what they did is they built a module system that allows people to kind of scratch their own itch. If they want to implement it, you can. You can basically take all the benefits and all the scaling characteristics and everything about Redis and implement it as C, C++, Rust, or any really systems programming language, and integrate it directly inside of Redis. And so it's not something that runs on top of Redis, it's something that is inside of Redis. Use a shared object file to integrate that in directly into your server. So this makes the commands first-class citizens, the data type first-class citizens inside the database. And it's not like there's any type of translation layer. This is running as a binary inside of Redis. So it's really interesting. But what it does is it enables Redis to become not just a key value store or a key value structure store, but really a multi-model database. And what we mean by that is that you can have different types of data residing side by side and potentially interacting with one another, all at the database level without having to go back out to the client and do all sorts of monkeying around with it and bring it back into the database. So this all happens at the database level. So if we take a look at things, instant multi-model requires a lot of different components, and this is where the kind of state of Redis is right now. And I want to kind of go through these. I won't go through them all individually because they're topics in and of themselves. I'll go through a couple of different things here, though. At the kind of the top of the circle, we have our native data structures, and that's kind of where it all begins. We have all these other modules that integrate into Redis, and they provide different capabilities. So, for example, you can make Redis a true graph database, and then you can add to it time series and store documents in JSON. And in the center here, we have Gears, which Gears is a really dynamic execution engine for Redis, which allows you to react upon data changes and do really things that were, and it's a very new module, that really these things before the release of this module just a few weeks ago would be pretty impossible. Really interesting things that you can do, and it allows you to interact with all these models and look at them together, and then traverse a cluster and do all sorts of these other interesting patterns that before were not really something that would be easy to achieve. So really Redis is changing quite rapidly, especially with the introduction of Gears and all these other modules. But today we're going to be focusing on this one. You probably guessed it, Redis AI. So you can see the brain and the kind of the lower side of the screen. So we've had modules for doing deep learning or machine learning for a while. This was kind of one of the first places we went to. The author of Redis, he came up with, as just a proof of concept of the modules, is neural Redis. And this was a experimental module. I worked a little with it myself for a complete neural network in Redis. It worked pretty good, but it was definitely, it was designed to both be on the training side and the serving side of it. And training, it takes such large amounts of data that it became, it's difficult to manage that, right? We had an experimental module for serving TensorFlow, and that's all it did. It was neat. It was a kind of a toy at that point, but it was really useful, and people saw some promise there. And then we had Redis ML, which allowed for kind of some very, very fundamental building blocks of the machine learning ecosystem to be integrated in. So they were take models were trained somewhere else and then kind of inject them into Redis. So the problem was it was kind of fragmented, and we didn't have a single fully featured AI module. In the last few months, we've really kind of worked towards that goal, like saying this is one AI module. So that's where and this is also a few weeks old as far as its official announcement, is Redis AI. We worked with a partner on this, TensorWorks, and we worked with them to create a really compelling solution for AI. So why do you need an AI serving at scale? And I will say this is about AI serving. This is not about the training portions of AI. That is something that we think there are great tools out there to do, and they don't necessarily need the real-time influence of Redis. So we think that at this point, continue what you're doing if you're training them somewhere else, and we'll take care of the serving. Is kind of where we fit in here. AI serving, what does it need at scale? And this is not just Redis, it's just general. If you're trying to scale out something in the AI world, it needs to run everywhere. It doesn't need to be restricted to one particular platform that uses a particular chipset or something along those lines. Multiple engines need to be available in that case. Data and computation, when you're doing calculations in Redis, boy, there's a lot of stuff, or calculations in AI rather, there's a lot of stuff that needs to move around. And the closer you can keep that data to the computation of the AI that needs to be predicted on, the AI model that needs to get predictions from, the better, right? That is really important. And then at the same time, you need to have this ability to have it to be a really enterprise grade, battle tested type of product. It's something that you don't want to run something experimental in, especially if you're building, say, a whole business around AI, right? So it needs to be on and inside that infrastructure in a way that can be easily scaled and clustered. So that's where we come in. You probably guessed that. Redis AI is basically AI where the data lives. So in this case, you may be running predictions on data that is already in Redis, or it might be very easy to get data into Redis and run those predictions. And then you can go and pull things back out of it. So everything occurs at the same layer. And I think that's when you think of the stack or the layer cake or whatever you might think of when you're thinking about an architecture, traversing those different layers is expensive from a computational standpoint, from a network standpoint. There's marshalling and unmarshalling, all sorts of things that become problematic at scale. So when you can do it where the data lives, that's a real advantage. So let's look at a traditional way of doing this, and then transaction scoring. So in this case, you're doing that kind of, going to a terminal and paying with something, or perhaps on a website. So some payment information is submitted to an application server by the end user, right? So that's step one. Step two, it goes to the regular database and pulls out some information that might be needed to validate that. That might be previous transactions. It might be something along the lines of demographic data, just all sorts of information that needs to be pulled out of the data store. That's sent back to the application server. The application server then does some vectorization on that piece of data that's coming in, both the payment and then some metadata around that. And then it's sent to the AI serving layer. So those vectors get sent around to it, and then a prediction is sent back, maybe a yay or a nay, right? So is this a good transaction or a bad transaction? And then it's, whoops, I might not remember. It went to, it's approved, yes or no. But you can see there's a lot of back and forth. This is that kind of traversal of the stack. Those are all expensive pieces of your performance, right? This takes up a lot of time. So before you get to the end of the time, it's 200 milliseconds. And if you know much about how human reaction times works, 20 milliseconds, 200 milliseconds is an eternity. If you click tap a button on the screen or click a button with your mouse, and it takes 200 milliseconds to respond, you're getting already frustrated at 200 milliseconds. Even though that seems like just such a fast amount of time, it's a frustrating amount of time. And it doesn't get any better when you start scaling. That's the fact of the matter. So as we go through, let's take a look at how Redis can help. So same idea. You have an application server. That application server is going to give you, or you're going to send that application server all the transaction information. You'll just take that and transmit it right to Redis. Right? In Redis, we already have the information that might be used to augment that data, and then we can run the model that we've already stored in our AI serving layer, which is then effectively also the Redis layer, and we can directly get the response back. So there's entire pieces of the stack that's removed by doing this, and so you can see it's sent back to the user almost directly. And not only is it faster, it's simpler. And so in this case, you can take a look at how long this might take. It might take 10 milliseconds for your app server to process things, maybe a millisecond in traversal, and then a millisecond in prediction. So you're less than 15 milliseconds when you're on that. 15 milliseconds is totally doable when you want to provide something instantly. It's not going to be frustrating, okay? So when we look at this, let's look more at what Redis AI can do and how kind of the different features and capabilities of it. We have new data types. We have tensors, right? And then we have different models that we can serve. Right now, TensorFlow is the predominant one. We have work on PyTorch and Onyx, increasing. Those are on the near horizon. And the other thing to keep in mind is that we can use CPUs and not only just CPUs on the server, but also GPUs. This enables us to do much faster parallel operations compared to the CPU, which is primarily a linear type of processor. Then we also have the ability to run a Torch script directly inside the server, and then we can get into how you can cluster it. So this is not only just the one CPU running or whatever. This is something that can exist in a massive cluster to enable high scale, to enable high speed. So it really changes this. Now, if you were trying to superimpose maybe your own homegrown version of serving an AI prediction, it would not look like this. There would be a lot of things that would not even be in existence. You might have one specific thing for TensorFlow, one specific thing for Onyx, and those are not portable effectively. So why do you do this? It really you're trying to put everything on the same layer. you're able to do everything inside the same piece of software that, and let's be honest, if you have 1.5 billion Docker pools, this is a common piece of software. It takes some very obscure tools and then really makes it accessible to developers who are maybe not completely trained in this, and it makes it very easy to develop these instead of something that might be specific for the serving layer. You know, with this, the same serving layer gives you blazing fast speed. You know, you can see exactly what's going on with your performance. Redis has plenty of integrations to monitor, and you know, you can serve the models that you're familiar with. So I want to give you an example, and we'll run a demo here in a moment using object identification, which is a pretty common thing to do in AI. You want to know what it is, and I think that the famous things that you've seen is from the show Silicon Valley. If you watch that, the hot dog, not hot dog, right? I think that's my favorite example of it, because it's, you know, people thought it was going to be brilliant, that it was going to identify foods and everything, but when actually it only identified one thing: it's make sure it's a hot dog or not a hot dog. Which I think back to all the time, and I think is a great example, and actually technically quite interesting why they chose that. But you know, object identification can be used in any number of things. As an example, you know, if you're in a self-driving car, object identification might identify that a stop sign's coming up, or it might identify that there's a pedestrian walking past, or identify that there's a deer in your path. Those sort of things would be vitally important. You might also be able to have something like the application Let Go, which is kind of like Craigslist almost, but you just take a picture of your item, and it does the item identification, says this is a brown drill or a blue refrigerator. It's kind of amazing that it can do that. So it's running some pretty sophisticated object identification. So it's a pretty wide used example, and we're going to get into how we're going to do it. Now, I want to go and talk about the different steps here. What we're going to be doing in this, and you'll see it all in its it actually running. So this is just to give you an idea of what we're doing. So one of the things we're going to do, we've already loaded a model into Redis, and I'm not showing this in this kind of very simplified version of the whole process. So we're going to go in and set some tensors, right? We're going to put a key to it, what type it is, and kind of some more metadata about it. And for our case with image identification, it's going to be a blob. Excuse me, it's going to be an entire image that we're just literally pushing into Redis. And of course, Redis is completely fine with binary data. So in this case, we'll be pushing data from a webcam. Then we're going to run a model on top of this, and we've preloaded this model in. So we'll take this tensor that we set, and that'll be our input, and our output will be kind of the prediction that we're getting out of it. And then we'll use ai.tensorGet to get that prediction out in a way that makes more sense. And finally, we're going to clean up some things because we created some keys, and we'll use the Redis unlink command for that. So that's an overview of all the AI stuff that really needs to go on here. It's really three commands. The important thing to keep in mind too is this is you know, Redis. If you're used to running Redis and you've used Redis in the past, you may have used like git and set and sadd and zadd and all these other commands. Really, there's not much more sophisticated to these commands. It's just a different name, a different command that you may be familiar with, and we're putting some different arguments into it. So really, it's functionally the same. There's no specialized things that you really need to do here. So from the perspective of the demo on a more kind of higher level, let's take a look at what's actually going to happen. So we have a webcam, and that's in Chrome. I'm going to use Chrome for this example because they have a good support for the webcam API. And then it's going to use some JavaScript, and in that JavaScript, is basically going to be able to take the webcam data. This is the JavaScript on inside Chrome, and then convert it into base 64. So on the server side, we have a Node.js script running, and this is basically just working as a web server. There's nothing sophisticated here at all. It's a web server that when it receives an application request, it runs a few Redis commands, and that's all it's doing. So it's really back and forth. It's bi-directional things. So we're sending things into Redis and getting things out of it. In the middle, we have WebSockets that connects everything. So that's how we're able to retrieve things without polling or anything like that. So we're just doing it asynchronously in this example. So let's go ahead and take a look at this. So I'm going to scroll over here. Everybody can see my screen, and you're going to get to look at me in these webinars. I don't often show my own face in them. It's just easier for you to pay attention to the slides if you don't have to look at how beautiful I am. On the top here, we're going to have a live webcam view, and then below we're going to have what we've captured. I'm going to capture it and effectively take a picture. Down here, we're going to show the commands that are being run in real time. So this is actually what the Redis server is seeing. It's just a small little viewer that we have of the active state of this application. So I'm going to start the demo, and hopefully you can see me. Hi, everybody. And then I have preloaded some things on my phone, some pictures of some animals, and we're going to see what that looks like. So in this, let's take a look at this. You probably know what this is. I would say it's probably a golden retriever. I'm going to take a picture. Whoops, I'll actually restart this. Hit the wrong button. Okay. Take a picture of this. Okay. And you can see this is saying it's a Great Pyrenees. That's probably about right. I'm not sure exactly what the breed of this particular dog is, but I want to pay attention down here to the different things that we're going in. We have an input, and this is just a randomized input for this particular example, some metadata around this, and then the blob, which is the image. I'm doing the model run, and so I'm taking MobileNet. And by the way, these predictions are nothing amazing. This is a demo application that is released, the demo model called MobileNet. And it does about 1,000 predictions on it. So it'll say it's one of these 1,000 items. So anyway, so I'm using MobileNet as my model, and then I am going in and taking this input. You can see those common things. And then I'm taking an output as well. And then I'm getting the tensor values out, and I'm getting the values out of it, and then sending it back to the web browser. And that's where this Great Pyrenees is coming from. So let's take a look at another image. I think this is a ridiculously cute animal. So I'm gonna take a photo of it. As you can see, this says it's a basset hound. And we can see these bytes, these things being run here. You can see we have a blob going into it, tensor set. We're running the model again, and we're getting the value out, and then we're unlinking. So 4 commands, not a big deal. Let's try it again. Look at this cute dog. Okay. Let's see here. Okay, this said it's American Stafford Terrier. That makes sense to me. Again, it's all the same stuff. I'm not doing anything specialized here. This is just Redis. Take another one. I bet this is also another Stafford Terrier. Yep, says it is. And then let's look at this guy. Sure, that makes sense to me as far as the breed is concerned. Maybe this is some sort of sled dog type of thing. Yeah, an Eskimo dog. Sure, that makes sense to me. Let's look at this. Now, this is obviously not a dog. What is this? Oh, it says it's a cat. It's a tabby cat. I don't know anything about cats, so I hope that's correct. But as you see and scroll through here, we're doing nothing really sophisticated. We're just running a few commands and then bringing it back to the web server. So let's return to the presentation. All right. Now let's take a look at, we did that. The other thing I want to talk about today is the swappable models in Redis. Now, this is something I wasn't able to demonstrate in our demo for a couple of reasons, but the reasons is more of the limitations of the models than anything. We have a very good model, and I wish I had a bad model or maybe a less sophisticated model that's built that I've imported into this particular version of Redis. But basically, as you saw, I was just running those 4 commands over and over and over again. There's nothing sophisticated there. So you can change the model at will, though. So if you remember, and I will swap back here, I'm running MobileNet as the model. I can just swap that out at any given time. So I can have one model, and then I can change it to another model. And maybe that model isn't working, so I can change it to another model. So really, you've created this whole generic serving layer. Nothing is really bound to it. So this enables some really cool patterns, right? So maybe you can want to A/B test a model. Maybe, for example, you have a model and you don't know how effective it is, and you want to compare it to another model. You can see which one is getting the right type of response from your users. So that would be really hard to do in a lot of other serving situations. This is as easy as saying 50% of the people get model 1 and 50% get model 2, and then measure the results. You can have user level configuration. Perhaps you want to have somebody who's a person who really wants to focus on dogs more than cats. So they have a model that detects all the different dog breeds and one that detects all the different cat breeds. And you could have that as a configuration that a user could change even. So that would be just as simple as this application. And by the way, this demo application is something along the lines of around 110 or 20 lines of code. So it's nothing sophisticated again. You could have, just by adding a few extra lines of code, you could say, no, actually, I want to change the model up and get something different out of it. You could have on an interval a replacement of it. So your model is replaced every hour or something as you're training new pieces to it. You get to do it every day. And the other thing I think would be super interesting to do with this is maybe have situations where you measure the load on your application, and in times where there is a cost to predicting things, and everybody has a budget for their infrastructure. Maybe instead of like upping your infrastructure budget, you have a simpler model that you run during peak times. So you're still providing some value, but maybe not as good as you would when you're not getting slammed. That way you can kind of moderate the amount of spin that you're going on with Redis, or excuse me, with your AI serving. And that's all enabled by Redis AI. So to get started on this, the first thing you need to do is probably go to redislabs.com/getting started. If you're brand new to Redis, that's a great place to get started. But if you want to dive into Redis AI, redisai.io, pretty easy to remember. That is a website that talks about to you how do you get started on this. It'll show you this getting started directions on it, how to build particular parts of this if you want to run it on your own server, or how to run it in Docker, so on and so forth. That's a great place to get started. At this point, I want to open it up to questions. Some questions have already came in. Let's take a look at some of those questions that have already came in, and I'll answer those. Let's see here. Can this be used in any programming language? So yeah, the question is yes. This can be used in any programming language. And Redis has clients in, I think it's something like 48 different languages, which is a lot of programming languages. Some are quite obscure, but nothing really special needed here to run these commands. To your application, they probably have provided some convenience features, so the programming language is a little easier to read, but there's usually always a way to send like what's called a raw command to Redis. And that would be as simple as sending the raw commands as I'm doing in this application. So very simple to do. So if you're a Java developer, if you're a Node.js developer, you're a Python developer, you're a .NET developer, there's really not a whole lot to jump into here. It's very simple, and it would be almost the same between languages. Okay, can this run in a cluster? So yeah, the question is, as far as running it in cluster, sure, there's no real difference here. When you're running these models, you're interacting with keys, and keys reside on shards, on nodes, and that's okay. There's nothing that say you can't cluster it. So this enables you to maybe have multiple models that are residing on different shards of your Redis instances, or you could potentially have read replicas where you're getting some of these pieces back out of it. There's lots of ways to cluster this that would be really effective and allow you to scale out. Okay, so does it always have to work with images from webcams? Okay, that's a good question, and this demo could lead you down that path, right? This works with anything. So if you're doing something much simpler, you're not sending an image over, certainly you could be sending in, as the example we gave, transaction data, right? You're trying to score if that's a fraudulent thing. That might be just like merchant A, time B, and amount C. Like 3 things being sent over, and you could run that against the model, and maybe you're augmenting it with data already on the server. So maybe you have some more information about person A, and you can pull that all together. So certainly nothing requires it to be on a webcam, and nothing requires it to be an image. It's just one of the capabilities of Redis AI. Okay, can you do anything with the resulting predictions in Redis? Okay, so the question here, I think what it means is that can you take the prediction? So as an example, we saw that it said that it was a Great Pyrenees dog. Can you do anything with that data afterwards, or do you just send it back to the user? So the interesting thing is, yeah, you can do lots with it. So you can run in different things. Like, for example, because it is a Redis command, you can actually throw it into Lua and run some of these things in Lua, and then store it in a list, for example. So if you had an application, just kind of expanding on this, you had a body cam and you were trying to walk around and see what dogs you ran into all day, certainly you could have something that would monitor it and detect the dogs out of it, and then add them to a list, and you could get at the end of the day a list of all the dogs you saw. That's totally achievable. So you could add it to more sophisticated things too. Think, for example, of maybe a search engine, right? So you could integrate it with perhaps something along the lines of search and add a document here and there, create some really interesting patterns by taking these different modules and putting them together, and creating something that leverages not only AI, but some of the other multi-model capabilities of Redis. Okay, looking at our questions, I'm not seeing much else today. Four good questions here. So at this point, I do want to say thanks, and we do have an upcoming webinar. My colleague Xavi is talking about event-based architectures, and that will be on the 24th, which I believe is next week. So come listen to Xavi's 45-minute webinar about how you can do messaging queue, event stores, and how that might look versus other things too. So again, thank you, and hope you get a chance to really work with Redis AI.